Okay, so what do we have on 3-2 homework? Oscar,
Can we look at 4B, please?
4B, 3-2 homework, 4B. Okay, so we're answering in radians, of course. So we want to know what is the radian measure of the angle that's represented by 11/8 of a rotation clockwise. Now, what does this mean? What does that tell me? That tells me that my angle is going this way, which means whatever I end up with is going to be negative. Now, a rotation, a revolution, is how many radians? 2 pi. So I simply take 11/8 times 2 pi. 11/8 of 2 pi, right? 11/8 times 2 pi. So that will be 22 pi over 8, which is 11 pi over 4. Is that what you have, and I marked it wrong?
No, I didn't put the pi.
Okay. What else, Bryce?
Can you just do all of number 2?
Number 2, I have an angle in standard position whose terminal side corresponds with the line y equals negative 4x. Now, what does that line look like? Y equals negative 4x. Goes through the origin. It has a slope of negative 4 over 1, y over x. So, 1, 2, 3, 4. The line looks something like that. It's supposed to be straight. Right? Now, terminal side of an angle in quadrant 4. So I am looking at this part of the line right here, quadrant 4. So I'm going to make a triangle because I am trying to find cosine, sine, and tangent. Now, do I have any idea how long the sides of that triangle are? No, but I do know that they are in the ratio 1 to negative 4 or negative 4 to 1. And remember, your trig functions are ratios. We don't need exact numbers. We're building a ratio, we're making a fraction. So I'm just going to go ahead and use 1 and negative 4. Now, a couple people use 2 and negative 8, which is fine. I don't know why exactly, but it's fine. You can use 3 and 12. Anything that's in that ratio will be on the line y equals negative 4x. So if I use these two numbers, which are the smallest option, then this would be the square root of 17, the hypotenuse of the triangle. So what's cosine? This is your angle now, right here at the origin. Cosine is 1 over root 17, x over r, think of this as a circle, or adjacent over hypotenuse. It's all the same, so it doesn't matter how you think about it. What sine? Yep. And then tangent will be negative 4. Okay? When in doubt, draw a picture. Okay, number 3. Number 3, an angle in standard position. The tangent is 5/12. The sine is negative 5/13. And I have to find the cosine. Well, there are a couple different ways you can do this. One thing I really want you to be thinking about, though, is which quadrant are we talking about? I want to draw a picture, like I did here. They told me I was in quadrant 4, so that was easy. If my tangent is positive, remember, tangent's y over x, and my my sign is negative, remembering that the radius of the circle is always positive. Hypotenuse is always positive. Doesn't this mean y has to be negative? But wait, if y is negative, doesn't x also have to be negative if the tangent's going to be positive? So they're both negative, so my picture is going to be drawn in quadrant 3. And the tangent is 5/12 y, or opposite over adjacent y over x. Those are both negative. And then if I do my Pythagorean theorem, my radius or hypotenuse turns out to be 13. So that I can look at my picture, what's the cosine? Negative 12. Okay? All right, I'll do one more. One more question from the homework. One more. 8? Now, I'm going to talk about this. Some of you, and God bless you, when you answered the questions, you remembered that there are infinitely many answers. If I say the sine is 1/2, there are infinitely many angles that have a sine of 1/2. That's the whole plus or minus 2 pi n thing. But in these problems, the direction said, give me the angles between 0 and 2 pi. So in other words, we're looking for all of the angles just one time around. No coterminals. Okay? So, number 8 says, where is the tangent 1? All the places, all the way around, where the tangent is 1. Well, having had all the discussion the last couple days about the unit circle, if you think about tangent as y over x, and you think about those key points here, if y over x is going to be 1, then don't your y and x have to match? And which angle does that happen at? Does that happen at pi over 6, pi over 4, or pi over 3? At pi over 4, right? Or, that's one way of thinking about it. Another way of thinking about it is, if the tangent has to be 1, then these two numbers have to match. That's an isosceles right triangle, so the angle has to be 45, which in radians is pi over 4. So either, it doesn't matter how you think about it, but you've got to somehow connect that if the y and x match, we're talking about a 45-degree angle, pi over 4. So in quadrant 1, the picture would look just like that. So one of my answers is pi over 4. Now, why did I say one of my answers? Well, if we come down here, then these are still the same, aren't they? And what angle would that be? That's your pi over 4 in quadrant 3, which is 5 pi over 4. Okay, now, question 9. Same exact concept, except it says the sign has to be -1. Now, I want you to think about that for a minute. That's y over r. They have to match. Your y coordinate has to be the same as your radius. Doesn't that mean that you're somewhere here? can't be out here somewhere. Because is it possible for your Y and your R to match? No. You have to be somewhere around a circle. So here's your unit circle. Where is it on the circle that if you put Y over R, you get -1? Where does that happen? Right there? And that's the only place. So that problem has just one answer, 3 pi over 2. Okay? All right. Now, I want you to get out your notes if you would. And I want to look at the back of page 15. Back to page 15. Okay? So, we did this yesterday, we did it the day before. We're just gonna fill in our values on our unit circle, okay? So for problem 3, what is the angle in problem 3? In problem 3, the angle is pi over 6. So you're going to fill in the coordinates for pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then you're going to answer the 2 questions, C and D. For number 4, you're doing the same thing, except the angle is pi over 4. And for number 5, the angle is pi over 3. So go ahead, fill in all the points, and then evaluate C and D for each one. Fill in all the coordinates and answer C and D for each one. So, one option. Because you know those. Then these are just assignments, right? So guys, if you're struggling, for the first one, for number 3, that's a 30 degree, a pi over 6, so pi over 6. So the coordinates in quadrant 1 for pi over 6 are root 3 over 2, 1/2. So what are they over here in quadrant 2? Negative root 3 over 2, 1/2. And then you have quadrant 3 and quadrant 4. That should not be confusing you. then once you have all those filled in, you can answer C and D easily. The sine of 7 pi over 6, negative 1/2, right? And the cosine of 11 pi over 6 is 3 over 2. Yeah, that's what you're supposed to be doing. Don't make it hard, it's easy. Remember, on the unit circle, x is cosine and y is sine. So if you can find your x and y, you got it.
Yeah, it depends if you rationalize it.
Anybody get an answer to 4C? Root 2 over 2, perfect. And how about 4D? Negative 1. Why is it negative 1? Because y and x are the same number, except one is positive and one is negative. Because you're down here. What are your coordinates for your pi over 3s? 1/2, root 3 over 2. Okay, so every pi over 3 is going to be those two numbers in some combination. Okay, so cosine 2 pi over 3, that's this one. Cosine 2 pi over 3 will be going to be negative 1/2. 2 pi over 3 is negative 1/2 root 3 over 2. And then tangent is either sine over cosine or y over x. So negative root 3 over 2 over, or excuse me, root 3 over 2 over negative 1/2, which is negative root 3 over 2 times, I keep saying negative, positive root 3 over 2 times negative 2 over 1. Did you get negative root 3 for your tangent? We do not want to struggle with that. Anna? I'm not, it's fine, I've got to figure out if that's gonna be a requirement or not, I just have that. So, it's fine, we don't want to do it for now, just so you know how to rationalize in case you have to. Okay. Now, I want to, we're gonna go back to the notes in a minute, but I want to try a couple of extra practice problems to make sure we did some of these in that one homework, but we're going to do a whole bunch of them tonight in our homework. So here's the given. Okay? Now, can anybody tell what size angle I'm talking about if the cosine is root 2 over 2. That's a 45, or in radians, pi over 4. Okay? So this is going to be one or more of my pi over 4s, right? Now, if the cosine is negative, then that means x is negative. And that means that I must be looking over here and here. So you've already figured out it's pi over 4. So which one is this in this one? 3 pi over 4. And this one is 5 pi over 4. Now because I limited you to one revolution, that's it. Those are the two angles that have a cosine of negative root 2 over 2. Alright, so we're kind of using our circle backwards now. We're looking at the coordinates in order to figure out the angle. Okay, let's try this one. Sine equals 1/2. So sine theta equals 1/2. Think about your circle. Which point has the y coordinate being 1/2? Well, I know it's not this one, right? It's not pi over 4. Pi over 4 is root 2 over 2. I need 1/2.
Pi over 6.
Pi over 6. And I think I told you this yesterday, maybe I didn't. I always think about, if these numbers, I know these are the numbers I use here and here, and if I'm worried about getting the order right, remember, if you're down here with this tiny angle, isn't the x going to be bigger than the y? So the root 3 has to, that number has to be first. So here are the coordinates that give me a sine of 1/2. And that angle is pi over 6. So I want positive 1/2. Isn't one of my answers pi over 6?
Yeah.
Where's the other one?
Cross that way.
Right over here? And which one is that? Which angle is that? 5 pi over 6. Okay, you getting the hang of that? I'm going to assign the 3-3 homework today, that we do on Tuesday. But one side of the page is I give you the angle, I find the sine of 7 pi over 6. Okay, that's one side. The other side is something like find where the tangent is 0. Okay? Now, let's do that one because it's a little bit different. First of all, it's a 0. Where will I look if the tangent, which is y over x, is 0? I am not looking here, am I?
No.
I gotta be looking somewhere on the axis. Where does it happen that the tangent works out to be 0?
Too high.
Well, and actually, if you look at these directions, we don't include 2 pi, we say 0. I know they're the same angle, but we use 0 because it's smaller. So one of your answers would be 0. Is there any other place where the tangent is 0? Isn't the tangent 0 here? I know that's a -1, but does it really matter? No, 0 divided by -1 is 0. So the answers are 0 and pi.
I have a question. Letter H.
Okay, what is it? What's the question?
Tan of the angle equals negative root 3 over 3.
Remember that negative root 3 over 3 is the rationalized revised version of -1 over root 3. Right? So you gotta think about this for a second. A couple of different options. If you're thinking about your circle, this point is root 3 over 2, 1/2. And this one is 1/2 root 3 over 2. It's gotta be one of those because it's gotta be root 3 in it. Now, remembering that tangent is y over x, then if I put y over x, won't that be 1 over root 3? So my angle's pi over 6, but it's a negative, so it wouldn't be in quadrant 1. Would this have a negative tangent? Yeah, so try pi over 6. Where else will the tangent be negative? Here? 11 pi over 6. Okay, there's a lot to think about there, but it's easy. No, it's hard. It's a lot. Okay, all right, so that homework is gonna be due on Tuesday. Now I want you to look in your notes at page 16. Page 16. And I want right now, you and your neighbor to do number 1. We should be able to do this at this point, guys. So you and your partner work together. And however you do it, we're gonna come up with these answers.
We just like picturing it.
Wait. Oh, I think it
So it's basically right here, because you go around 2 high, 2 high, yeah, so it's 7. So if it's the cosine, what is the x, the 0, yeah. Good.
All right, we got them done? We need more time. I want everybody to have an answer to every question.
To the training.
All right, let's see what you got. This is a 4 pi, this is a pi over 3 angle. So I'm thinking about this coordinate right here, pi over 3. It's cosine, so I'm thinking about x. And it's 4 pi over 3, so I'm thinking about quadrant
2.
3. It's bigger than pi,
Oh,
bigger than pi. So I'm thinking about quadrant 3. And if I'm thinking about x in quadrant 3, it's negative. The answer is -1/2. Guys, this is not hard. We shouldn't be struggling. Let's get it. By Monday, we're not struggling anymore. 7 pi over 4. That's this point. I'm doing sine, so I'm thinking about y. And it's 7 fours, so it's all the way around in quadrant 4. Y in quadrant 4 is negative, so that's negative √2/2. Pi over 6, I'm thinking about this coordinate. But it's 5 pi over 6, so I'm thinking about that coordinate in quadrant 2. And its tangent, which is y over x, only x would be negative in quadrant 2. So when I simplify that, I get -1 over √3 or -√3 over 3. 7 pi, oops, 7 pi is not one of these. It's a whole pi. Where is 7 pi located? Right here. Because all the way around is 2. So there's 2, 4, 6, and another half. So I'm over here, which is what point on my unit circle? -1, 0. I want the cosine. Cosine is x over r, or on the unit circle, it's just x. So the answer to the question is -1. Now, raise your hand if you and your team got all those right. Very good. Okay, maybe I'm worried about nothing. Okay, very good. All right. Now, number 2 is kind of a dorky exercise, but we need practice evaluating. So there is no one correct answer. What they want you to do is tell me why A doesn't fit, why B doesn't fit, why C doesn't fit, and why D doesn't fit. I guess they're not labeled. I labeled them. I call this A, B, C, and D. All right, so see if you can evaluate them and then figure out if there's any reason that it's different from the others. Any reason, don't make it hard. Is there any reason that A is different than the other 3, or B, or C, or D? You're doing all 4 of them. They're all 4 different in some way.
5 pi over 6, quadrant 2. Let's go all the way around.
So we're doing an argument.
Yes, yes, you're doing argument for
So
each.
it's like right up there.
So why does A not fit with the others? Why does B not fit with the others? And don't overthink it. Some of them, like I said, it's kind of a dorky exercise. Let's see what we can come up with. Now you will want want to evaluate them all. So you'll want to find out what the value of each one of them is, which you know how to do.
That means that one is one house.
Just making sure.
Isn't it just like, wouldn't you just add C to get the counterclockwise one?
This one's counter.
Oh, that's right.
This one's
Come up with any reason that it's different. Doesn't have to be anything super sophisticated.
It's like if you think about this, like counterclockwise, this is one pi, and negative one pi would be the same as this one.
So A is the only one that isn't the fourth quadrant.
So then, the sine root of negative. Oh my gosh, this one is root 3 over 2.
Yeah, it is.
Wait, what? Sorry? Five pi over 6. It is me.
All right, what did we come up with? First of all, what are the values here? What's the sign of 2 pi over 3? Root 3 over 2.
I think I'll lose.
Root 3 over 2? What's the cosine of 5 pi over 6? Negative root 3 over 2? How about the sine of negative pi over 3? Negative root 3 over 2? And the sine of 11 pi over 6? Okay. Anybody have a question about any of those numbers? Okay, right off the bat then, I'm gonna go out on a limb here and say D is different because one reason it's different is it's the only one that's not plus or minus root 3 over 2. Did anybody have another reason D was different? Okay, so what did you decide about A? What made A different? It's the only positive value? Okay, what made B different? It's cosine. It's the only cosine question. Yeah, perfect. And what made C different? It is a negative angle. That's right, so its rotation is different. Is that okay with everybody? All right. one more quick thing. I'm not gonna spend a lot of time on it, period's almost over. Gotta get going. But on the problem number 3, we have an angle of 5 pi over 3. So we're down here at 5 pi over 3. Okay? Now, your job is to find the coordinates of point A, B, and C. Now, A, I contend you already know, because A is the unit circle, right? So what will be the coordinates of point A? It's a pi over 3 angle in quadrant 4. So that would be 1/2 negative root 3 over 2. Is that okay with everybody? So the cosine of that angle is 1/2, and the sine of that angle is negative root 3 over 2. Now, keep in mind, a couple days ago, we talked about the fact, well, we've been talking about it all day, cosine is x over r, so x equals r cosine. So if I want to find the coordinates of point B, that's the radius is 2, so don't I just take 2 times the cosine to get the x coordinate, and 2 times the sine to get the y coordinate? And then I'll do exactly the same thing for point C, except the radius now is 3. Easy. Done. Got it? All right. Go ahead and get your phones, go back to your seat, get packed up. And we will, oh, everybody should have gotten the next set of notes. Did I get everybody with the next set of notes?